Hi everyone. Today we're going to study composition of functions. The process of combining functions so that the output of one function becomes the input of another is known as a composition of functions. The resulting function is known as a composite function. We represent this combination by the following notation. This is the notation, and this is read as f composed with g at x. And we will simplify this notation by this, and this is read as f of g of x. Further, composition is a binary operation that takes two functions and forms a new function. There is a note that in general, the f of g of x and g of f of x are different functions. Let us have example 1. We have two functions here, function f and function g. The f of x equals 5x plus 3 and g of x equals 1 minus x. Find letter A, f composed with g at x, and b, g composed with f at x. Let us write the notation here, and let us start with letter A. The f composed with g at x is equal to f of g of x. Let us now simplify the right side. First, let us simplify the inner function, the g of x. We're going to copy the value of g of x. The 1 minus x is now substituted here. So we have now f of 1 minus x. And then let us evaluate the f of 1 minus x in terms of the function f. So what we will do is, we will copy this 5x plus 3 in here. However, for every x that we see on the right side, we will change by the 1 minus x. So this 5x will become 5 times the quantity 1 minus x, and then plus 3 is copied here. And then we will simplify further. The number 5 is to be multiplied to 1 and to the negative x. So we have 5 times 1 is 5, and then 5 times negative x is negative 5x, and then the plus 3 we will copy in here. To simplify further, we will combine this 5 and the 3. So we have 8 minus 5x. So this is now the value of this f composed with g at x. The 8 minus 5x, we will simply write this opposite letter A. So we have here the answer 8 minus 5x. We will now proceed with letter B. The g composed with f at x. So we are going to write the g outside, and then f of x will be inside the function. So to simplify this, we will first substitute the value, this 5x plus 3, we will put in here. So we have now the g of 5x plus 3. And to simplify this, we will go to the function g. We will write again this right side value in here, but every time we see an x, we will substitute that by this 5x plus 3. So we have now 1 minus x, and this x becomes the 5x plus 3. And from here, we will simplify further. The grouping symbol is preceded by a negative sign, and we know what to do. We will change the sign of all the terms inside this grouping symbol. So we have now 1 minus 5x minus 3. To simplify further, the 1 minus 3 becomes negative 2, and then the negative 5x is copied only. So we have now this negative 2 minus 5x. This is the value of g composed with f at x. And this value we will simply copy here. The g composed with f at x equals negative 2 minus 5x. And we can see here that the f of g of x, this is letter A, is not equal to g of f of x, which is the letter B. And we have this as our final answer. Let us have number 2 example. There are two functions, function f and function g. The f of x equals x squared plus 1, and g of x equals the square root of the quantity x plus 2. Let us simplify A, f composed with g at 5, and letter B, g composed with f at 5. Let's begin with our letter A. To simplify this, let us start with the inner function g of 5. It means we will copy this function, but every time we see an x, we will change by the value 5. So we have now the square root of x plus 2 becomes 5 plus 2. You see, we substituted the value 5 to the x. And then we simplify further. The 5 plus 2 inside the radical symbol will become 7. So we have now this function f of square root of 7. Now, to evaluate this function, we are going to use the f of x, and we will copy the function here. But every time we see an x, we will change that by the value square root of 7. So now the x squared plus 1 becomes the square root of 7 plus 1. Then we will simplify further. We can cancel the square root and the square. Only 7 comes down, and plus 1. And then we can combine 7 plus 8. And this 8 is the value for f composed with g at 5. And we can write this 8 opposite letter A. We can now proceed with letter B. G composed with f at 5 is equal to g of f of 5. Let us first simplify the inner function f of 5. We will go to the f of x here. We will copy again the function x squared plus 1. However, this x will be replaced by the number 5. So we have now the x squared plus 1 becomes 5 squared plus 1. And then we will simplify. The 5 square is 25, and plus 1, we have now the g of 26. To evaluate this, we will go to our g of x, and we will copy this value, the square root of x plus 2. But every time there is an x, we will change that by the value 26. So we have now the square root of the x plus 2 becomes 26 plus 2. And to simplify further, we simply get the sum of 26 and 2. It is 28. So we have here the square root of 28. To simplify further, this 28 is not a perfect square number. So we will split 28 into factors, and one factor must be a perfect square number. And the factors are 4 and 7, because we know 4 times 7 is 28. And this number 4 is a perfect square number that we can move out of the radical sign. So the final answer is 2 square root of 7. This value is our g composed with f at 5. And we can copy this value opposite letter B. We can see here that the f of g of 5, which is the letter A, is not equal to the g of f of 5, and that is letter B. So we have now the final answers here. Example 3. If f of x equals x squared and g of x equals x plus 2, find A, f of g of x, b, g of f of x. Let's begin with problem A. Let's write the problem here. Then let us evaluate. We substitute the value of g of x inside this grouping symbol. Our g of x is x plus 2. So we replace the g of x by x plus 2. Now we have f of x plus 2. Then we evaluate the function f. Our f of x equals x squared. So we change the x by x plus 2. So we have the square of x plus 2. Then we expand. So finally we have the answer, x squared plus 4x plus 4. This is the answer for problem A. Then we solve for problem B, g of f of x. In here, what we do is we substitute the value of f of x. We have here f of x equals x squared. So we put it here. So we have g of x squared. Then we evaluate g of x squared. Our g of x is x plus 2. So we change x by x squared. Then plus 2. So we have this value. Example 4. If f of x equals x plus 5 and g of x equals 1 over x minus 3, find A, f composite g of 2, b, g composite f of 1. Let's begin with problem A. Our f composite g of 2 we can write as f of g of 2. Then we evaluate g of 2. Our g of x equals 1 over x minus 3. So we change this x by 2 for the g of 2. So we have 1 over 2 minus 3 inside here. Then we simplify. The 2 minus 3 is negative 1. 1 over negative 1 is negative 1. So we have f of negative 1. Let us now evaluate f of negative 1. f of x equals x plus 5. So we change the x by negative 1 for this f of negative 1. So we have negative 1 plus 5. And when we simplify, it is positive 4. This is the answer for problem A. Let's copy this answer opposite A. Then we proceed to B. G composite f of 1. We can rewrite this as g of f of 1. Let us now evaluate this f of 1. Our f of x equals x plus 5. So we change this x by 1 for the f of 1. So we have the g of 1 plus 5. And the sum is 6. So we have here g of 6. Let's evaluate g of 6 using this g of x equals 1 over x minus 3. So we change this x by 6 to evaluate this g of 6. So we have 1 all over 6 minus 3. And in the denominator, the difference is 3. And we write 1/3 opposite problem B.